All right, in today's video, we are going to be talking about parallel and perpendicular lines. So thinking about those two words, parallel, is talking about two lines that never cross. So if two lines never ever cross each other, like this, that would mean they have, and this is very important, write this down, the same slope. If two lines are perpendicular, they would have slope. So those are lines that intersect to form a right angle. So that would look like lines that look like this. They cross at a perfect X. In order to have perpendicular lines, the slopes are what's called an opposite reciprocal. Reciprocal is a big word that we talk about in math, which basically means we take a fraction and we flip it upside down. So there's a couple examples. If we have the slope 3 over 4, the reciprocal would be 4 over 3. So we flip it. If we have the number 2, that is a whole number. So we know it's divided by 1. So to have the reciprocal, we would flip it upside down to become 1 over 2. So if we're talking about perpendicular lines, they say it's an opposite reciprocal. What does that mean? Well, let's do an example down here if you need to write it. So let's pretend we have the slope like 2 over 3. The opposite reciprocal would flip the fraction, and it would also change the sign. 2 over 3 was positive, so the opposite of that would be negative. Let's do one more example of an opposite reciprocal. So if we started with a negative 5 over 6, the reciprocal would flip that fraction upside down to be 6 over 5. And since it was a negative, it's going to become a positive, opposite. Okay, so let's look at some examples. Looking at the first example, let's start by graphing these. So our first equation says y equals 2x plus 1. My b in that equation is positive 1. So I'm going to begin at positive 1 on my graph. And from there, my slope is 2. So that tells me I'm going to go up 2. And it wasn't divided by anything, so over to the right 1. Continue that as far as you possibly can until you run out of graph. Since I ran out of graph, I'm going to go the other way as well. I'm going to go down to left 1 as far as I possibly can go. Down to left 1, down to left 1. And I'm going to make my line. All right, let's graph our second equation. It says y equals 2x minus 5. So I'm going to begin at negative 5, and I'm going to count my slope. It is also 2 over 1, so I'm going to go up 2, right 1, up 2, right 1, until I run out of graph. Just like the other example, I can do the opposite and go down to left 1. And I'm going to connect my dots. So looking at these two lines, they're never crossing, which means the answer to our question, are the following equations parallel, perpendicular, or neither? Since these lines never crossed, that means they are parallel. And we can also see that because our slopes were exactly the same. They both had a slope of positive 2. All right, let's look at the next example. We're going to graph the next two. Our first equation, y equals 4 over 5x plus 2. We are going to begin at positive 2. And then our slope is 4 over 5. So I'm going to go up 4, right 5. And I'm going to do that again. It looks like I got room. Up 4, right 5. Okay, since I ran out of room, I'm going to go the opposite direction. Down 4, left 5. Do it again. Down 4, left 5. And I'm going to connect my dots, and I'm going to put arrows on the ends. All right, let's graph that second equation and see what happens. Y equals 2x minus 1. In that equation, my b is negative 1, so I'm going to begin at negative 1 on my y-axis. And I'm going to count my slope. My slope is 2 over 1, so I'm going to go up 2, right 1, as far as I possibly can. Looks like I ran out of room, so I'm going to do the opposite and go down 2, left 1, as far as I can go. I'm going to connect my dots now, and let's see. Are they parallel? Well, they crossed, so they're not parallel. Are they perpendicular? They do cross, but in order to be perpendicular, they would have to cross at a perfect T shape or a perfect X shape. And they don't. So in this situation, I would say neither. They're not parallel and they're not perpendicular. Which, looking at our slopes, this one was a 4 over 5 and this one was a 2 over 1. They're not exactly the same to be parallel, and they're not reciprocals of each other, so they're not perpendicular. All right, let's look at the next example. So let's graph this one. Our slope is 2 over 3, and our b is negative 1. So I'm going to begin at negative 1. And to count that slope, I'm going to go up 2, right 3. Since I ran out of graph, I'm going to do the opposite, and I'm going to go down 2, left 3, until I run out of graph. Down 2, left 3, and I got a perfect line, so I'm going to connect my dots and put my arrows on the ends. All right, my next equation is negative 3 over 2x plus 5. So since it's plus 5, I'm going to begin at positive 5. And my slope is negative 3 over 2. So I'm going to go down 3, right 2. Down 3, right 2, as far as I possibly can go. Now I can do one more. All right, I ran out of graph, so I'm going to do the opposite, and I'm going to go up 3, left 2, which looks like I can only do that one time. So I'm going to connect my dots and put arrows on the ends. All right, so in order to be parallel, these lines could not touch, and they touch. So they're definitely not parallel. Are they perpendicular? They are crossing at that perfect X shape. And if we look at our slopes, this one was 2 over 3, and this one was a negative, so opposite of the positive, and the fraction flipped. So these are perpendicular. If you want to just abbreviate it, you can do that. You don't have to write the full word. All right, let's do a little practice with these slopes. Just practicing what a parallel slope would look like and what a perpendicular slope would look like. So looking at this example 1 down below, let's talk about parallel and perpendicular slopes. So if we have an equation with a slope of -3, a parallel slope would be exactly the same. It would also be -3. Or if you want to put -3 over 1 to make it a fraction, you're more than welcome to do so. For the perpendicular slope, we would have to do two things. Since it was a negative, I need to make it opposite and make it positive. And I need to flip the fraction. I need to do the reciprocal. Become 1 over 3. All right, our next slope is +5. So the parallel slope would be exactly the same. Positive, if you want to really show, and it's not a fraction, so +5 over 1. To say the perpendicular, we got to make those two changes. Since it was positive, the perpendicular would be negative. And we need to flip our fraction, so 1 over 5. All right, let's do another one. Our next slope is 5 over 2, so that's a +5 over 2, which means our parallel slope would be exactly the same, +5 over 2. For a perpendicular slope, we got to do those two changes. Instead of positive, a perpendicular slope would now be negative, and we would flip it upside down to be 2 over 5. All right, last example. Our slope is -6 over 7. So a parallel slope would be exactly the same, -6 over 7. The perpendicular slope, we would, instead of being negative, now it would be positive. And let's flip it upside down to be 7 over 6. All right, let's look at another example about parallel and perpendicular lines. So figuring out if they are or are not parallel or perpendicular. So to do so, we need to identify what the slope is of each of these lines. So our first equation they gave us was -x plus 4y equals 3. Well, I'm not sure what the slope is because this doesn't say y equals. So I'm going to solve for y on this problem. So always, I'm going to solve for y. I'm going to add that x first because it was -x, leaving me with a +4y equals 3 and a plus. If you want to put that 1 in there, it was a 1x. So now I'm not done solving for y. I'm going to divide by that 4 on both sides of that equation, leaving me with y equals 3 divided by 4. Let me use my calculator. Gives me a decimal, so I'm going to hit math, enter, enter. So it's just a 3 over 4. That's okay. Again, I need to divide in my calculator. 1 divided by 4 is a decimal. I don't want that. Math, enter, enter, is a +1 over 4. And don't forget the x. So of this first equation, my m is 1 over 4. So let's see, what is my slope of my other equation? And let's decide if it's parallel or perpendicular, or maybe neither. My second equation was 4x plus y equals 12. So I'm going to solve that for y again because I need to know what the m is. So to solve for y, I'm going to get rid of that 4x. So I'm going to subtract 4x on both sides because it was positive. So now I have y, or a 1y, it's all, the y is by itself now, how nice, equals 12 minus a 4x. Well, there you go. I have my equation solved for y. I don't need to do anything else. I can see that my m is right here, a -4 or a -4 over 1. So my slopes are not the same, so they're not parallel. And they are fresh, so let's see. This one was a positive 1 over 4. And this one was a negative 4 over 1. So it went from positive to negative, and the slope flipped upside down. So it would be a perpendicular. They are perpendicular lines to each other. All right, let's look at another example just like this. The next one they gave us, they have two equations here. Let's look at our first equation. It is 3y equals negative 4x plus 6. So I need to figure out what is the slope of that equation. It doesn't say y equals though, so let's solve it for y. It looks like I need to move the 3. So to get rid of that 3, I need to divide by 3 on both sides of my equation. Leaving me with y equals, that's what I wanted, negative 4 divided by 3 gives us a decimal, so we're going to hit math, enter, enter, and it's a negative 4 over 3. Don't forget the x. And 6 divided by 3 is 2. So now that we have it in y equals, I can see my slope is a negative 4 over 3. Let's compare it to the slope of the second equation. Let's look at it and see what we think. Here's our second equation. It's already solved for y. So I can see my slope is a negative 3 over 4. So let's think about this. I notice it's a 4 over 3, and this one flipped to be 3 over 4. So I might be perpendicular. But in order to be perpendicular, one would have to be positive and one would have to be negative. Both of these slopes are negative. So it is not perpendicular. The slopes are not the exact same, so it's not parallel. So these are neither parallel or perpendicular. To practice this, you're going to go to Delta Math. Unit 2, there is one called Parallel and Perpendicular Lines.